We've now indexed, updated, deleted, and retrieved documents. That was pretty easy, wasn't it? Perhaps one question comes to mind though. How does it work under the hood? Particularly, how did Elasticsearch know on which shard to store the documents? And how did it know on which shard to find an existing document, be it to retrieve, update, or delete it? The answer to both those questions is routing. In its basic form, routing refers to the process of resolving a document's shard, both in the context of retrieving the document, but also to figure out on which shard it should be stored in the first place. When we index a document, Elasticsearch uses a simple formula to calculate on which shard the document should be stored. You can see the formula on your screen now. I'll get back to what underscore routing is soon, but by default, this equals the document's ID. The same applies when we update or delete documents. What happened when we retrieved a document by its ID was that the same formula was used based on the ID that we specified. Elasticsearch then knew that if the document existed, it had to be on the shard that the routing formula yielded. The same applies for updating and deleting specific documents. Searching for documents based on some criteria other than their IDs works differently, as you'll see when we get to writing our first search query. As you have seen, routing is entirely transparent to us as users of Elasticsearch. By providing a default routing strategy, Elasticsearch is much easier to use than if we had to deal with this ourselves. Did you notice how I said default routing strategy? That's because it's possible to change the default routing. I won't go into detail with this now, because that's a slightly more complicated subject that we'll look at later in the course. Apart from ensuring that documents are allocated to a shard and that we can retrieve documents by ID, the default routing strategy comes with another benefit. It ensures that documents are distributed evenly across an index's shards. If we were to change how documents are routed, we would either have to ensure that documents are distributed evenly, or accept that one shard may store significantly more documents than another shard. Elasticsearch stores a bit of metadata together with the documents that we index. As you saw when we retrieved a document, the JSON we specified when adding a document is stored within an underscore source field. You also saw that a document's identifier is stored within an underscore ID field. Another meta field is the one named underscore routing, which you saw in the routing formula a moment ago. Since the default routing strategy uses the document's ID, you won't see this underscore routing field as part of the query results. That's because it's only added if you specify a custom routing value when you index documents. That's essentially what routing is. Before ending this lecture, I want to tell you something interesting. Do you remember how the number of shards cannot be changed once an index has been created? If we take another look at the routing formula, then we can actually see why. Because the number of shards is used within the formula. If we were to change the number of shards for an index, then the routing formula would yield different results. That's not a problem when indexing new documents, but it would cause big trouble for existing documents. Suppose that we have an index with 2 shards, and that we indexed a document. Shard number 2 was the result of the routing formula, so that's where the document was stored. Let's imagine for a moment that we were able to increase the number of shards for the index, and that we increased it to 5. We indexed some more documents and all is well. However, when we try to retrieve specific documents based on their ID, Elasticsearch is sometimes unable to locate the documents. That's because the document's ID is then run through the routing formula again, and since one of the formula's variables has changed, the result may be different. If that is the case, Elasticsearch tries to find the document on the wrong shard, and thus returns an empty response, even though the document does exist. That's not the only reason why additional shards cannot be added to an index though. Another problem could be that an index's documents would be distributed very unevenly. As a quick reminder, Modifying the number of shards requires creating a new index and reindexing documents into it. That's made fairly easy with the shrink and split APIs though. Anyway, that was just a little bit of bonus information for you.